Hello, I'm Gabriela, PhD student of Federal University of Santa Maria, Brazil, and I will present the paper entitled Hygrothermal Analysis of 6 Wooden Vertical Ceiling for the Brazilian Bioclimate Zone 3. So, as you know, the presence of the moisture in the building is one of the main factors responsible for user discomfort, as well as market degradation of the building elements. Water can also have other different effects, such as freezing deterioration and loss of bonding between layers due to vapor condensation and interfacing between building layers. In addition, can indirect effects as chemical attacks on natural stones, corrosion of concrete elements, among others. Thus, it is of utmost importance to analyze the hygrothermal behavior of the building's materials and building system considering the weather conditions to which they are exposed to predict their durability and internal environment quality. So, this work aims to analyze the hygrothermal performance of 6 different wood wall systems in Brazilian Bioclimate Zone 3 with PROS software versions 6.3 and easy to identify the moisture flows and the thermal performance in a building located in that ZB3 in Brazil. For the methodology, the city chosen to represent Bioclimatic Zone 3 was the city of Porto Alegre, and the climatic file used was the TRI provided by the lab, and 6 models of wooden walls were analyzed that I will show you in the next slide. And below are the climatic data used for this paper of Porto Alegre. So, the first system is composed of almost 1 centimeter of softwood. The second system has 2 OSB panels with 5 centimeters of air in the middle. The third was exchanged this air layer for 10 centimeters of mineral wool. And the fourth is the same as system 3, but with an air layer close to the inside of the building. Fifth is the same as system 4, but with an air layer close to the outside. And for the last, the system 6 also features with 1 centimeter of hydrophobic blanket. For the calibration of these 6 models, the following parameters were defined: solar orientation to the north, small buildings, external and internal walls with the acrylic paint, ground reflectivity, shortwave was 0.2, incident rainfall reduction factor of 0.7. To flow integration tests, the results indicated that the constructed system S1 presents excellent performance regarding to the capillary transport and for steam transport. The S2 system results in the system more susceptible to capillary transport, followed by X6, but when this phenomenon occurs, the flow is directed outside the building in the both cases. Also, the S2 system had the highest moisture content of steam incorporated. Comparing all the systems as the flows of steam transport, S1, S2, and S3 system transported steam into the building, whereas S3, S4, and S5 transported it out of the building. The risk of condensation is verified in the wood when the dew point temperature is higher than the temperature in a certain position of construction system, reaching a relative humidity close to 90%. In this figure, we can see the temperature, red line, and the dew point, violet line, show that in all systems the dew point was below the average temperature, demonstrating that there is no risk of condensation. And the lowest risk of condensation occurred in the S3, S4, and S5 system due to the great difference between the internal temperature and the dew point temperature. The figure 2 shows the relative humidity and moisture content of the system analyzed. The blue and green lines represent, respectively, the moisture content and the relative humidity of the construction system at the end of the simulation, that was 2 years. So, doing a quick analysis, when comparing all systems, the S2 system presents the best result regarding the probability of water condensation. And for more details, are present in the paper. As we can see here, with the heat flux vector in the positive x direction and in the negative x direction, that all systems arranged the heat flow outside. And the S5 system with mineral wool tangent to USB panel presented the best heat flow performance. In view of the moisture flow analysis, it was found that the S2 and S6 system showed the best results. As conclusion, from the result obtained, it was possible to verify the importance of carefully studying the wall system to be used in the buildings. And in this study, we can see that all systems indicated positive results for capillarity transport flow. And regarding the vapor transfer, the system S3, S4, and S5 show positive results, directing the vapor outside the building. And S4 system presented the highest risk of condensation when compared to the same position of the other systems. And for the last, the S5 system with mineral wool tangent to USB panel presents the best overall performance for ZB3. This is the reference used to this presentation. So thank you for your attention, and any question you can contact me in the email above.